everyone. Mendeleev gave the first periodic table of elements. Mosley put forward the modern periodic table of elements. Group 17 elements are called as halogens, meaning salt formers. Valency is defined as combining capacity of an element. Hi, I am Latha. Welcome to our channel for the new session of ICSE Class 10 Chemistry. We have completed 5 chapters of biology and 2 chapters of physics. Those who are new to my channel, kindly check out the link for the videos of physics and biology. Please watch my videos, and if you like my videos only, please subscribe my channel and support me. Welcome back to our channel. As our daily routine starts and end up with chemicals, and these chemicals do live and become a part of our everyday life. Let's discuss about a chemical and its harmful effects before my videos of chemistry. As we were discussing story of the day before my biology videos and scientist of the day before my physics videos. Thus, let's go to the chemical of the day. Milk. Once upon a time, milk was considered as the safest and healthiest food. But nowadays, it is adulterated with unhygienic water, hydrogen peroxide, chalk powder, soap water, and even urea. Shocking, isn't it? If we consume this milk mixed with the above chemicals, it causes food poisoning, heart-related problems, and even cancer. What are the home remedies for this? Boil this milk as many times as you can and then cool it simultaneously. After boiling, keep it in the fridge for cooling. How much ever you boil it, the same time you have to cool the milk. Second tip, adding lukewarm water to this milk will separate mostly milk and the cream out of it. That is chemical of the day. Welcome back to the new session of Chapter 1 ICSE Class 10 Chemistry. That is periodic table, periodic properties and variation of these periodic properties. Before going into the lesson, let us discuss the basics of this unit. What are elements? We know what are atoms. Atoms are the tiny particle or smallest unit of any matter. Atoms only make up matter, either it is solid, liquid or your gases. Then what are elements? Elements are also the next group of atoms makes an element. Elements are further divided into metals and non-metals depending on their properties. What are properties? We say boiling point, we say melting point. You might have heard about all this. Temperature or its reaction with water, its reaction with hydrogen gas or its reaction with acid. All these are called properties of an element. So, based on properties of element, elements are divided into metals and non-metals. So, elements will have a specific characteristic features. Okay then, how are these elements discovered? So, let's discuss about the discovery of elements. So, let's see. Elements, we have seen the definition of elements. Then, the discovery of periodic table. Initially, they have discovered only 10 to 11 elements. That was only very easy and very commonly found elements they found out. And How are this placed? These elements are not arranged as such like that. They have to be placed in a proper order, isn't it? Then people won't accept. There are almost 11 elements only that were discovered, and 11 elements also people found it confusing because each element has different properties of itself. So, next came the first scientist who arranged these elements in a proper order was Dobriner. Dobriner. He arranged those few elements into triads. As the name says, it is triads. Triads. That is, he named the similar elements into three groups. That is, three in a group. Three elements in a group actually. Okay. So example are calcium and barium. What is the speciality of this law of triads? According to Dobriner, the first element, the middle element and the last element. He, as I said, he arranged three elements in a group. If you sum the first element and last element and average and find average for those two, you will get the atomic number of the middle element. That is law of triads according to Dobriner. Next came Newlands. This Newlands discovered few more elements and he placed it according to his law, which is called as law of octaves. As the name says, octaves. Octaves was arranging elements into 8. That is, in a group, he arranged 8 elements. Okay, and he said the first element and the last eighth element seems to share the common properties of itself. The first element seems to be similar in few of its properties with eighth element. So that is what is law of octaves. Octaves. This was also, this both where, because as days passed on, new elements were being found out. They have like placed only till 20, only till calcium they could have placed. They were successful in placing them in according to octaves, that is 8 in a group. Then after then, they couldn't find any similarities in the properties between first element and eighth element. So that was proved failure. Then came the very famous scientist Mendeleev. Dmitri Mendeleev. He gave the first periodic table of 63 elements. He arranged all the elements according to their atomic masses. And he said Mendeleev's periodic law was the properties of elements are the periodic functions of their atomic masses. As I said, how did he arrange those elements? We cannot as such arrange like that. For example, for your school assembly, children are arranged according to their heights, not according to their weights. They are all arranged according to their heights, one behind the other. Likewise, Mendeleev has got 63 elements in his hand. He has to arrange it for people to accept, isn't it? People won't accept if everything is kept properly. So, he arranged those elements according to increasing order of their atomic masses. The first element atomic mass, say it is 1. The second element will be little bit more than first element. That is, it will be 2 or 3 or more than that. So likewise, he arranged the elements according to their atomic masses. And there was few, like when Mendeleev arranged those elements in a periodic table, he found there were 63 elements. And while his arrangement, the vertical columns were called as groups. So Mendeleev called vertical columns as groups and horizontal rows were called as periods. So Mendeleev called vertical columns of the periodic table as groups and horizontal rows as periods. And let's discuss about this periodic table in detail. in this chapter is completely about this periodic table only. Either it is Mendeleev's periodic table or the next scientist, the next new modern periodic table it is. We will discuss about periodic table in detail. But there were few drawbacks for Mendeleev's periodic table. What are they? Number one, he didn't discuss or he didn't leave place for the isotopes. We also have rare earth elements or isotopes for few elements. We know what it is. In your lower classes, you might have studied about isotopes. Mendeleev didn't leave any place or didn't leave any blank for those isotopes in the periodic table. That's the first drawback of Mendeleev. Second drawback, he didn't undiscovered elements. He didn't even mention about the newly discovered elements. Where will they be placed? He has arranged all 63 elements in a periodic table completely. Then where is the place for the newly going to discover elements? There's no place for the newly discovered elements. That is also one of the drawback. Third drawback, he didn't left blanks, and few blanks he has left. For what it has been left blank? Who will occupy those? So that is unknown. So those three are the drawbacks for Mendeleev's periodic table. Next came Henry Moseley, who said the elements are being arranged according to their atomic numbers. He said it is very easy for the elements to get arranged according to their increasing atomic numbers, but not according to their atomic masses, as Mendeleev said. So thus, Moseley's new periodic law states that the physical and chemical properties of elements are periodic functions of their atomic numbers. That is modern periodic law. Then, as already discussed, groups. What are groups? As I already said, if you look at the periodic table, there are totally 18 vertical columns which are called as groups. So, totally there are 18 groups in the modern periodic table. So, which has same number of elements in its outermost shell. So, every vertical column, if you see, the outermost shell has the same number of elements. Yes? Next, left to right. So, this vertical columns from left to right in the increasing order of their atomic numbers. Next, group 1, they are called as alkali metals. What are alkali? When these metals are dissolved in water, they form alkali. That is why they are called as alkali metals. Group 2. Group 2 elements are called as alkaline metals. That is, they don't form strong alkalis as group 1 elements. Group 3 to 12. Group 3, 4, 5, 6, 7, 8, 9, 10, 11 and 12. They are called as transition elements. Transition. What do you mean by transition? They transfer their electrons according to the reaction. They don't have permanently stable electrons in its outermost shell. They, according to the need of reaction, according to the bond formation, they transfer the outermost electrons. So that is why they are called as transition elements. Group 13. They are called as boron family because the group 13 begins with element boron. Next, group 14 is called as carbon family because the group starts with carbon. Next, group 15 is called as nitrogen family because the group starts with nitrogen. Group 16 is called as oxygen family because the group starts with oxygen, and they are also called as chalcogens. Next is group 17. Group 17 elements are called as halogen family. Halo means salt formers. That is, when any metal reacts with another metal, it forms salts easily. That is why they are called as salt makers or halogen family. Group 18, the last one, group 18, they are called as zero group elements. That is, they are very distant and unique among other groups of elements because they are absolutely inert in nature. What do you mean by inert in chemistry? Inert means very passive. Take for example, there is a class of 10 students and teacher is teaching class. When she is asking questions, if all the students answers for her, then the class is said to be active. If the teacher is asking question and students are not answering, nobody is answering for the teacher, then the class is said to be very passive. Or I will say in chemistry terms, the class is said to be inert. Same way, there are few elements which are inert in nature. That is, they don't react with other elements easily. They don't join or mingle with any other elements easily during chemical reaction. Yes, why are they doing so like that? They are not mingling with anybody. In a class, in our class also, there will be few students who doesn't make friends with anybody. There might be some reason for that, isn't it? Likewise, there are few elements, that is elements of group 18 called as zero group elements. They don't react with any other element easily as other elements does. That is why they are called as inert group elements. Inert means they don't react or they have very, very low reactivity. What is the reason behind it? Because they are inert due to the completely filled electronic configuration in the outermost shell. Till group 17, it has incompletely filled shells or partially filled electronic configuration. What is configuration? The arrangement. Configuration is arrangement. Electronic configuration means the arrangement of electrons. We can see the nucleus around which we have electrons revolving around it. So every orbit, you can say every shell around the nucleus will fit only certain number of electrons. For example, the next shell close to the nucleus, that is the first shell next to the nucleus, can fit only 2 electrons. The next shell will fit almost 6 electrons. The next shell will fit almost 10 electrons. And the final shell can fit only 14 electrons. That the final shell which fits your 14 electrons is considered as outermost shell. Okay, likewise, till group 17, the outermost shell is not completely filled. It will have either incompletely filled or half filled configuration. But the zero group elements have completely filled configuration. I will tell you a very good example. If your stomach is completely full, you don't feel like eating any other food. When you go for a marriage, you will have a very complete heavy meal, isn't it? Your stomach will be full. You will have 20 to 25 different types of items, ending up with ice cream also, isn't it? So you don't feel like eating after coming to home. That is what is happening for the zero group elements also. It has completely filled. All the shells are completely filled. It doesn't have to react with any other element. Yes, that is the reason being inert in nature. So zero group elements are also called as inert group elements. Inert group elements, and most of the zero group elements are noble gases. Example. What will be the example? Your krypton, your xenon, your radon. They are noble gas elements. So groups, as I said, groups 1, 2, 1 this side, 1 to your left side, 1 and 2, and this side from 13. In between, I am leaving 3 to 12. I am counting 1, 2, 13, 14, 15, 16 and 17. They are called as representative elements because they have First group elements have 1 electron in its outermost shell. Second group elements have 2 electrons in its outermost shell. 13th group has 3 electrons in its outermost shell. 14th group has 4 electrons in its outermost shell. 15th group has 5 electrons in its outermost shell. 16 has 6 electrons in its outermost shell, and 17th has 7 electrons in its outermost shell. They are also called as representative elements or main group elements because they are the main group or the elements which participate almost in all chemical reactions because their stomach is not full. They have partially filled stomach or half filled stomach. If we are not satisfied with the food whatever we ate, if our stomach is half filled or partially filled, we feel like eating more. That is what is happening for this group elements. Its outermost shell is half filled or partially filled. So it needs more electrons. So it will borrow or get from other elements. Thereby will participate in a chemical reaction. Next, that's all about groups. Moving on to periods. What are periods? As I already said, the horizontal rows are called as periods. How many horizontal rows are there in modern periodic table? There are 7 horizontal rows in a modern periodic table. They are called as periods. Each period begins with 1 electron. That is, in the beginning of the period, the first element has 1 electron in its outermost shell, and when the period ends, the last element in the period ends up with completely filled configuration. That's the beautiful arrangement of modern periodic table. I'll again repeat, each period, that is your horizontal row, begins with an element which has 1 electron. The next element has 2 electrons in its outermost shell. The third has 3 electrons in its outermost shell. Fourth, 4, fifth element has 5 electrons in its outermost shells, and so on, and ends up with the completely filled configuration. That is your completely filled configuration at the end of the period. Next, the number of shells determines its periods. For example, how will you name the period 1? Means the particular elements will have only one shell. Period 2 means the number of shells are 2. Period 3, the number of shells are 3. Period 4, the number of shells are 4, and so on. So elements of period 1 have one shell. Elements of period 3 has 3 shells. The next two groups are lanthanides and actinide group of elements. Talking about lanthanides, lanthanides are also called as group 3 of 6th period. As I already said, 6th period, they belong to group 3. 7th period, actinides belong to 7th period and group 3. They are also group 3 elements only. Group 3 elements, what are they? Group 1 elements are alkali metals, as I already said. Group 2 are alkaline metals. Then group 3 are D block elements, that is the one which is in the middle from 3 to 12 are group 3 elements. So this lanthanides and actinides also lie in between 3 to 12. So that is why it is group 3 elements from group 3 elements of the periodic table. So in that group 3 also, lanthanides form the top. It form the top period, that is your 6th period, and actinides form the bottom, that is your 7th period. They both together been separated from the periodic table and kept at the bottom of the periodic table, removed from the middle block, and they lanthanides and actinides are kept separately down under the periodic table. Okay, that's all about the groups of elements. Next very important property is your periodicity. periodicity, which means variation. Variation in what? Its properties, either physical property or chemical property. Definitely, the elements in the same group or in the same column or in the rows, whatever it is, they have either similar or dissimilar properties. So this variation, actually the one that belongs to the same that is vertical columns and horizontal rows should be the same, but some of them they are not similar, they are dissimilar. So this variation you call it as periodicity. So periodicity is the properties that reappear again at regular intervals. Periodicity is not only the variation, some of the properties reappear again for few elements. Okay, maybe in terms of electronic configuration, if we see, some of the elements, outermost electrons, valence electrons are, if it is 2, then for few elements, it has 2 electrons only. So those 2 elements will have similar chemical properties, which you call it as periodicity. So the properties that reappear at very regular intervals, or it will vary also at regular intervals. If it is similar also, it appears at regular intervals. If it is varying also, it appears at regular intervals. So there is something change. Either it is similar or varying. Both appear at regular intervals equally. That is what is called as periodicity. What is the reason of this similarity suddenly and dissimilarity or variation? The reason is their only culprit is electronic configuration. What is electronic configuration? The arrangement of electrons in the outermost shell or its valence shell. Valence shell, number of valence electrons. So some of the elements have similar valence electrons in the outermost shell. This is the reason why those two elements have share the same chemical properties or vary in chemical properties is also because of the same electronic configuration only. That you call it as periodicity. Periodicity means if a few elements share the similar properties because of its electronic configuration, similar electronic configuration, and some of them may vary at regular intervals, so which is called as periodicity. Next, the chemical properties depends completely on number of electrons in the outermost shell. Just now we were discussing the chemical properties of any atom or any element depends on number of elements present in the outermost shell. Next, valency. What is valency? You will say it is the combining capacity of an element. What do you mean by combining capacity? What is combining capacity of an element? Let me say this combining capacity. An element combines or reacts with some other element which you call it as valency. Let me tell you an example. Let me take magnesium as an example. What is the symbol of magnesium? It is Mg. Mg is the symbol of magnesium. What is its electronic configuration? What is its atomic number first? Magnesium has atomic number 12 and its electronic configuration is 1s2, 2s2, 2p6. Till here it is 10 and remaining you have 2. So what is that? 1s2, 2s2, 2p6. Then next one 3s2. Isn't it? So this magnesium has 12, actually 2, 4 and this one is 6 and totally 12. This is the electronic configuration. Now what is this magnesium doing? What is the valence shell or outermost shell? How many number of electrons it has? 2 electrons it has. So if it have to react with some other element, it has to lose these 2 electrons. Yes. So that is what is combining capacity. What is the valency of magnesium here? You will call it as, what is the valency of magnesium? It is the number of valence electrons in the outermost shell. It is 2. So magnesium's valency is 2. Is this complete? No, it's not complete actually. It has to get charge either plus or minus. Valency is always denoted by plus or minus symbol. So who will get plus? Who will get plus? Isn't it? Who is called as plus? Normally, if something good is doing, if someone is doing good, we will call them as plus. If someone is harming us, we will call them as minus. Isn't it? So magnesium, what is magnesium doing? It is having 2 electrons, 2 more electrons for itself. So it does not hold it. It wants to give those 2 electrons to other element. So is it doing good? Is magnesium doing good for the other element? Yes, it is doing good. It is donating its valuable electrons to the other element. Isn't it? So if somebody is doing good, what did I say? The particular element will get plus. So magnesium will be getting plus. Yes? Right. Next, let me take chlorine as an example. What is the atomic number of chlorine? It is 17. What is its electronic configuration? 1s2, 2s2, 2p6, 3s2 and 3p. Totally till here it is 10. This is 2. 12. And how much is left? 5. Isn't it? Yes. So what is this chlorine? Chlorine, if you see, outermost shell has 5 electrons. It is partially filled. Of course, it is partially filled. As I already said, its stomach is partially filled. It's not completely filled. So what chlorine will do? It will try to fill its stomach completely. So chlorine tries to fill the shell. So how many electron it needs to fill its shell? Only 1 electron. It will try to get that 1 electron from some other atom. Yes, some other atom it will try to get. So, what is the next we were discussing? Magnesium is ready to give 2 electrons for chlorine. But chlorine don't have space to fill those 2 electrons. It can fill only 1 electron. So, magnesium has 2 electrons ready in hand. This hand 1 electron, this hand 1 electron. Magnesium has. But only chlorine, one chlorine has only 1 hand. So, it can take up only 1 electron. So, what it does? Chlorine is calling its friend, another chlorine friend, to get 1 electron. Magnesium is there to give 1 electron to us. So please come. As the another chlorine is also friend of this chlorine, both wants 1 electron only. So now 1 electron of this chlorine, 1 electron of another chlorine. So magnesium has 2 electrons in hand. So this hand, it is giving 1 electron to one chlorine and this hand 1 electron to another chlorine. Now magnesium stomach is overfilled, na? So it has given those 2 electrons. Now magnesium has flattened its stomach, completely filled. Isn't it? It's stable, it happily fills. Then chlorine. Chlorine, 2 chlorine it has. I said chlorine number 1 is calling chlorine number 2. Isn't it? So both 1 electron it got. So it is also stable. It is getting stable electronic configuration. So what will be the formula? Magnesium will get, as I said, whoever is donating, whoever is doing good will get plus. So this chlorine has received. It is receiving. It is begging from magnesium. So it gets minus charge. So chlorine will get -1. Isn't it? So 2 chlorine. So magnesium formula is MgCl2. That is why magnesium formula is MgCl2. Now that's not our target. Our topic is valency. Now tell me, what is the valency of magnesium? With how many electrons it is combining with other elements? It is 2 electrons. Isn't it? So valency of magnesium is 2. What 2 it is? Plus 2 or minus 2? Is it donating or is it begging? It is donating. So it gets plus 2. So what is the valency of magnesium? Plus 2. Now valency of chlorine. How many electrons it is begging? 1 electron. Since it is begging, it will get minus. So chlorine is minus 1. Valency of chlorine, you will say it is minus 1. Yes, hope you understood what is valency. We have seen what is periodicity. Now it is periodic properties. We have few periodic properties to talk about according to the periodic table. What are these periodic properties? These periodic properties are the properties that are related to your electronic configuration. What is configuration? I already told you. Configuration means arrangement. What is arranged here? Electrons. The only hero of the periodic table is number of electrons. That is your electrons. So, according to the arrangement of electrons, these periodic properties may vary or be similar. That is what we will be discussing each and every periodic property in detail. Yes, let's see the first one, atomic size. It is. So, periodic property is related to electronic configuration and they show gradation. Gradation means the variation. So, across a period we will see and we will discuss even down the group. So, down the group what is the periodic property and across a period what will be the gradation of periodic property we will see. First periodic property is your atomic size. What do you mean by atomic size? Atomic means atom. The size of the atom. How will you determine the size of an atom? What does atom has? Atom has number of orbitals or shells around itself. Isn't it? Take for example, we have hydrogen. Hydrogen, how many electrons it has? What is its atomic number? Hydrogen is 1. And same way for sodium, what is the electronic configuration of sodium? It is atomic number is 11. Hydrogen is 1 and sodium is 11. So hydrogen has 1 electron and sodium has 11 electrons. 1 electron means around the nucleus, the hydrogen atom has only 1 shell. It's enough. Then all the other shells are empty. Whereas here for the sodium, if you see, sodium has nucleus and then 11 electrons. So it has first one, the second one and third one also. Now 1 electron is being filled. Yes, so based on the number of shells, the atomic size is being depending on. See, let's see. How will you define atomic size? It's the distance between the center of the nucleus and its outermost shell. It's called as atomic size. If you see, assume this is your nucleus of one atom and nucleus of another atom. So, the distance between nucleus of two atoms are called as internuclear distance. So, internuclear distance. The internuclear distance is measured by an unit called 1 angstrom. What is 1 angstrom? 10 to the power minus 10 meter. Okay, this is internuclear distance, not the atomic size. What is atomic size? Here I have drawn. So, this is your nucleus. This is shells. These are the shells. See, for this is one atom, this is one atom, this is another atom. See, for the first atom, if you see, this is your nucleus and the number of shells. See the distance? The atomic size is small. And for the next one, the number of shells has increased. So, the distance also from nucleus to the outermost shell has increased. Then for the third one, if you see, the number of shells even more were increased. So, the distance from the nucleus to the outermost shell has also increased. Yes, increased. So, the atomic size depends on number of shells also. As the number of shells increases, the atomic size also increases. That is what they mean here. So, atomic size depends on number of shells, and second property is nuclear charge. Nuclear means nucleus. What is the charge for the nucleus? It carries positive charge because it has protons in it. Protons are positively charged. So, the charge for the nucleus is plus. What is the charge for the electrons that is revolving around? Minus. So, what is the work of plus? It will try to attract the minus. And thereby it gets the nuclear charge is the positive, number of positive ions in it. So, as the nuclear charge is increased, the size decreases. You may ask me, madam, why the nuclear charge is increased? As the nuclear charge, number of protons kept increasing, the plus charge increases for the nucleus, and the nucleus will become more powerful. So, the most powerful plus giant nucleus will try to pull the electrons towards itself. Isn't it? A big giant, a big demon will always try to demolish the little ones around. Isn't it? So, nucleus being the very strong giant tries to pull the little electrons that is around itself towards itself. Isn't around it towards itself. So, that is what is nuclear charge. Nuclear charge being plus tries to pull or attract the electrons towards itself. So, in that process, the shells comes closer to the nucleus. Since nuclear charge is trying to pull the electrons, so electrons are trying to move towards the nucleus and the shell size will decrease, come close to the nucleus. So, size of the shells or the number of shells becomes closer to the nucleus. So, the size of the atom also decreases. That is the reason why nuclear charge increases, the size of the atom also, the size of the atom decreases. Next is trends in atomic size, down a group and across a period. Let's see down a group. Down a group, atomic size increases. As we go down the group, the element's atomic size keep on increasing. This is because of addition of more shells. As I already said, number of shells increases, the atomic size also increases. That is the only reason. For example, we'll see hydrogen. It has only one shell and its atomic size is 37 picometer. Picometer is 10 to the power minus 12 meter. 1 picometer is equal to 10 to the power minus 12 meter. Next, for potassium, it has 11 electrons. So, 11 electrons means atomic size is 186 picometer. Okay, this is down a group. Next, across a period, the atomic size decreases. The reason is nuclear charge increases. I already said what is nuclear charge. Nuclear charge, nucleus being positive charge tries to pull the negative charge towards itself. So, when it is trying to pull the electrons towards itself, the atomic size naturally gets decreases. So, for an example, we will see second period, lithium being the first one will have largest size and the fluorine across the period it's the almost the last one having the smallest atomic size. Next, in the third period, sodium having the largest size and chlorine has the smallest atomic size. Now, there are few exceptions. The size of the atoms of inert gases. I already said inert gases occupy the last group of the periodic table, that is 0th group element. They are inert gases. They are much bigger than the halogens of the same period. Yes, halogens of the same period, they are just the previous group. Yes, the 17th group are your halogens. Okay, they are 18th group. So halogens are just, they are bigger than the halogens of the same period. Why? Because of the completely filled electronic configuration. We already know 0th group element will have the completely filled electronic configuration. The outermost shell will have completely filled electrons in itself. So if the electrons are filled, they don't react with anybody. Yes, and the nucleus also will never disturb the outermost shell which is completely filled. So the atomic size also remains the same. A nuclear charge also, nuclear charge does not affect the atomic size getting decreased. So that is the reason inert gases has to be smaller, but it is bigger than the halogens. Because of completely filled electronic configuration being very strong, a nucleus cannot attract the or pull the outermost completely filled shell towards itself. So that's all for this video for today. Hope you all understood chemistry chapter 1 of ICSE class 10. That is your periodic table and periodicity. And in my next video, I will be discussing few other periodic properties and its variation across a period and down the group clearly, with many examples. So, if you like my video, please don't forget to like my video, share it to your friends, and don't forget to subscribe my videos. Please watch my videos, don't watch my videos without subscribing. Yes, and don't forget to leave your valuable comments in the comment section. Thank you.